Good morning to all my YouTube viewers. In this video, I like to discuss about atomic structure of Bohr's model of hydrogen atom. The purpose of this video to give a gist study materials to those students who needs it to prepare their material on fast track basis, and it will be a very much supportive for their board exams and other competitive exams which will be facing within 3 months. Let us start. Number 1, radius of orbit, which is being calculated from Bohr's postulates and electrostatics, that is r suffix n equal to n square h square epsilon naught divided by pi m e square z, or r suffix n equal to 0.53 into n square by z angstrom. For hydrogen like atom, r suffix n proportional to n square by z. From here it is understood that orbits are not equally spaced, it varies. Number 2, velocity of electron in N-Ath orbit v equal to E square by 2 epsilon naught Ch into Cz by n, or v can be simplified to alpha Cz by n, where alpha equal to 1 by 137, and it is called Sommerfeld's fine structures constant. It is a constant. So, v equal to alpha Cz over n. Now, from these two 1 and 2, we can see Rn equal to 0.53 n square by z is a simplified form, and v equal to alpha Cz by n also very simplified form. These two formula are easy to keep in mind, and you can solve all kinds of problems with the help of these two. Now, orbital frequency of electron. Orbital frequency of electron f equal to mz square e to the power 4 over 4 epsilon naught square n cube h cube, or f is proportional to z square by n cube. Now, from this simplified form, that f is proportional to z square by n cube, we can easily tackle problems. So, this we can keep in our mind without any failure. This is very useful formula, and problems are coming on this. Now, it is found that velocity of electron in the on orbit, that is v n suffix n versus z, is a straight line. From the above formulas, it is found that the velocity is directly proportional to z, and again velocity of electron with quantum number, it is found that it is rectangular hyperbola in nature. Now, come to 4, energy of electron in N-Ath orbit. Now, here E equal to minus m e to the power 4 over 8 epsilon naught square Ch cube into Ch z square by n square. The simplified form is minus Rch z square by n square, where R is known as Rydberg constant, its value is 1.097 into 10 to the power 7 1 meter. Now, the simplest form we can make by calculating minus Rch part, and that is comes minus 13.6 electron volt. Then we can find out expression for energy will be minus 13.6 into z square by n square for hydrogen atom or hydrogen like atoms. So, this formula will be highly useful to calculate energy for electrons. Now, come to number 5. For only for hydrogen we can write E suffix n equal to minus 13.6 divided by n square electron volt. If n is 1, that will give you ground state energy, then n equal to 2, it will give minus 3.4 electron volt, that will be for L shell, and when n equal to 3, it will give us 1.5 minus 1.5 electron volt for M shell. Now, all these data are important, we can keep in mind, or we can derive it. It is better to keep in mind. Number 6, frequency of emitted radiation, that is F equal to minus Z square RC within bracket 1 by Nf square minus 1 by Ni square. From here we can find out frequency. Now, wave number, that is 1 by lambda, will give us minus Z square R within bracket 1 by Nf square minus 1 by Ni square. Then come to 8, hydrogen like atom. We know hydrogen like atoms are helium plus, lithium plus plus and beryllium plus plus plus, where helium has Z equal to 2, lithium Z equal to 3, for beryllium Z equal to 4. Now, ground state energies for hydrogen, helium, lithium and beryllium as it is given, that is minus 13.6 for hydrogen, helium plus minus 54.4 electron volt and lithium minus 122.4 electron volt. Next, number 10, ionization energy and ionization potential. The minimum energy required to move from ground state to n equal to infinity is called ionization energy of the atom. Now, for hydrogen, ionization energy will be 13.6 electron volt, and for helium it is 54.4 electron volt, and for lithium plus plus it is 122.4 electron volt. And ionization potential will be, for hydrogen is 13.6, for helium plus is 54.4 and for lithium is 122.4 volt. Now, come to excitation energy, that and excitation potential. Ground state energy for hydrogen it is minus 13.6 electron volt. Fast excited state energy is minus 3.4 electron volt. So, difference is giving 10.2 electron volt. That is the amount of excitation energy. And binding energy, energy required to move an electron from any state to infinity, that is called binding energy. Now, come to 13, that is limitation of Bohr's model. There are 4 limitations, mainly 4 limitations are there. Applicable for hydrogen like atom only or hydrogen atom. And number 2, Bohr's atomic model could not explain hyperfine spectral lines. Bohr's atomic model could not explain electrons disobey electrodynamics. Number 4, Bohr's atomic model could not explain splitting due to electric and magnetic field. Now, from all above data you can see that radius r suffix n and jet plot is rectangular hyperbola pattern, and r suffix n and the quantum principal number is a parabolic type pattern will come, and r suffix n and n square is directly proportional, it is a straight line. These diagrams are very important in multiple choice questions or any other form it can come, so we have to take care of it. Now, we will solve few problems which are very important and it will give you a boost in this chapter to solve various problems which are available in your books. The ground state energy of hydrogen atom is minus 13.6 electron volt. What are the kinetic and potential energies of electron in this state? We know energy total equal to energy kinetic plus potential energy. Now that is equal to minus m square over 8 epsilon naught square n square h square, that is giving as minus 13.6 electron volt. Now as we know, kinetic energy is m is e to the power 4 by 8 epsilon naught square n square h square. Therefore, potential energy will be double the kinetic energy total, double the energy total. That is, kinetic energy will be minus 13.6 electron volt, which will give you 13.6 electron volt. That is the amount of kinetic energy, and potential energy will be U suffix n, that is 2 times total energy, that is 2 into minus 13.6 electron volt, that will give us minus 27.2 electron volt. This is a very important problem. Now next problem, problem number 2. What is the ratio of radii of the radius corresponding to fast excited state and ground state in a hydrogen atom? Here for fast excited state n equal to 2, we know that r suffix n proportional to n square. Using this formula, we can write R2 by R1 equal to N2 square by N1, and N2 equal to 2 square divided by 1 square will give us 4:1. Number 3. In the Bohr model of hydrogen atom, the ratio of the kinetic energy to the total energy of the electron is, we know kinetic energy equal to minus E total energy. So kinetic energy divided by E total energy will be minus 1. That means answer 1 is the choice. Now come to question number 4. Determine the minimum wavelength of a photon that can cause ionization of helium plus ion. Now we know that total energy equal to minus 13.6 into z square by n square, where z equal to 2, n equal to 1, then we will get minus 54.4 electron volt. Now ionization energy is 0 minus 54.4 electron volt will give us 54.4 electron volt. The minimum wavelength of a photon will be hc by ionization energy, and h is 6.63 into 10 to the minus 34 into 3 into 10 to the power 8 over 54.4 into 1.6 into 10 to the minus 19. From here we can get 22.8 nanometer. Next question 5. The ratio of ionization energy of Bohr's hydrogen atom and Bohr's hydrogen like lithium atom, there are 4 choices we have to see. The energy of electron in ground state of an atom is given by, that is E equal to minus 13.6 z square. Then ionization energy will be 13.6 plus 13.6 z square. Now we know that energy for hydrogen ionization is 13.6 into 1 square, whereas divided by energy for lithium will be 13.6 into 3 square. As it is atomic number is 3, so it will give us 1 by 9. So choice number 3 is our answer. Now question number 6, an electron is revolving in the N-th orbit of radius 4.2 angstrom, then the value of N is, we know the ground state radius is R1 equal to 0.529 angstrom. Now as we know, R1 proportional to N1 square and Rn proportional to N square. Now using these two, Rn divided by R1, it will give us N square by N1 square equal to N square by 1 square, and Rn is provided, that is 4.2 angstrom. So putting this and now Rn is provided 4.2 angstrom and R1 is 0.529 equal to N square by 1. From here N will be 2.81, which is close to 3. So our choice will be choice number 4. Number 7, the ionization energy of lithium plus plus is equal to 9 H here, 6 H here, 2 H here, H here. We have to solve it. Energy for ionization will be minus HCr z square within bracket 1 by n infinity square minus 1 square. So when this will be n infinity means it will be 1 by n infinity will give you 0. So answer will come 9 HCr, where for lithium it is z equal to 3. Now question number 8, in which of the following Bohr's orbits in a hydrogen atom emits photons of lowest energy? Now if we start from ground state to first excited, second excited, third excited, fourth and fifth and so on, you can see the space between them gradually decreases as it goes outer cell side. Now it is found that E2 minus E1 of course greater than E3 minus E2, because energy gaps reduces, and similarly E4 minus E1 greater than E4 minus E2. So from here it is found that E4 minus E3 will be the lowest one. So H nu will be lowest for E4 minus E3. So your answer will be choice number 4. Thank you very much. My all wishes are with you. If you find anything good here, you can share, you can like it, you can subscribe, so that I can continue my process. Upcoming videos will be very soon for next chapter. So thank you very much.